Sesi ni pun bagi kerja last minute, masa dah tak payah berani nak submit. Phone je lah. Gue matiin set pun ni. Aduh, dah habis bateri. Aku bocas tadi kot. Aduh, kerja banyak lagi ni nak buat.
Assalamualaikum.
Salam.
Pasal ni?
Kata aku buat kerja sesi pagi tadi. Aku buat handset aku mati lah.
Lah, kau tak charge full ke?
Aku dah charge tadi lah. Tapi itulah bateri phone aku ni cepat turun lah bateri dia.
Ya. Asal lah? Ha, aku tahu apa masalah dia. Mungkin handphone kau power consumption dia tinggi. Power consumption? Consumption tu apa?
In this video, I will explain about 4x4 array multiplier. For introduction project, multiplier play a significant role in high-speed digital signal processing. It's the most important part of the arithmetic logic unit, FPU and ASIC, where the low power is required. Currently, the importance of low power design increases rapidly due to the increasing demand for portable mobile system. Next, the gates are used in 4x4 array multiplier. As we know, AND gate, half adder and full adder are important components in applications such as digital signal processor architecture and microprocessor. There have three important gates are used in 4x4 array multiplier. Firstly, AND gate. Secondly, half adder, and lastly, full adder. Next, the function AND gate, half adder, and full adder. The function AND gate is to multiply input, and function of half adder and full adder is to sum internal signal from the output of AND gate, and we can get the output 4-bit array multiplier. For first design, I designed AND gate, half adder and full adder using CMOS technique and combine all of them and get the output from this design. For demonstration, I will show how 4x4 will function. Firstly, the top and left side are for the 4x4 input. After that, AND gate will work to multiply the input value that has been entered. And now, half adder and full adder will work to sum of bit value from AND gate output. Lastly, the right side will serve as the output of the 4x4 array multiplier. And now, I'm using testbed to see the waveform of output 4x4 array multiplier. When to insert the input, I'm using pulse voltage source to apply input waveform. For DC voltage, will function to give supply to pulse voltage source. From testbed, we can get the waveform 4x4 array multiplier. From this waveform, we can see 8 input and 8 output will generate. To make it easier to understand how a 4x4 array multiplier works, we can see an example of a multiplier equation. A and B as an input and P is for output. Pulse transistor technique. Pulse transistor logic, or PTL, describes several logic families used in the design of integrated circuit. It reduces the count of transistors used to make different logic gates by eliminating redundant transistors. Transistors are used as switches to pass a logic level between nodes of a circuit, instead of a switch connected directly to supply voltage. This reduces the number of active devices. Concept AND gate pass transistor. In this gate, if the B input is high, the top transistor is turned on and copies the input A to the output F. When input B is low, the bottom pass transistor is turned on and pass a 0. Combined with CMOS technique. Finally, for my second design, I combine half adder and full adder, static CMOS with AND gate pass transistor are successfully simulated according to its function from the 4x4 array multiplier result paper. This method will be the main comparison to the other method. Result and finding. Based on result taken in mental graphic from the static CMOS design and CMOS with pass transistor logic design, comparison between static CMOS design, total power dissipation is 1.45 microwatt and static CMOS with pass transistor logic is 1.091 microwatt. For this result, will be compared with the result from research paper. Okay, next, for comparison, I will compare my result and with research paper result. From research paper is 47.24 microwatt. Differences between technology can affect the power consumption. Research paper that I discover use 180 nanometer technology. My proposed design uses 130 nanometer technology, and by reducing transistor used in the design can affect the power consumption reduced massively. Total of 0.3659 microwatt is reduced between static CMOS design and my proposed design. Target market. For target market, I target more focus on industrial and institute. Benefit on this project is can be reduced transistor count and low power dissipation. 4 P's. Firstly, price. For price is depend on the customer demand for design, and secondly, affordable price. Next, product. This product provide low power consumption on device that use on design. Next, place. First, industrial, and secondly, institute. For promotion, first, good service and design, and lastly, discount 50% for next design.
Hi, my name is Aizuddin. That's all for my project. Thanks for watching my video.